In this exercise, we're going to demonstrate inheritance by creating a base class called account and a derived class called checking account, and demonstrate how we can use inheritance to minimize the amount of work we have to do to create the derived class checking account from the base class account. So let's get started. Our base class is account. It'll have one protected field, the balance. Our first public function will be the constructor, and the constructor will simply check to see if the balance entered, which will be the amount to set up the account, is greater than 0. Then we set the balance equal to the balance. Otherwise, set the balance equal to 0. So in other words, you could not create an account object with a negative balance. Next, we're going to create a function called credit, which is simply an amount added to the balance, as you can see. Then we'll write a method called debit. Here we'll say if the balance is greater than the amount, then subtract that amount from the balance. Otherwise, write out that dreaded message, insufficient funds. And then finally, we'll write a getBalance function to return the current balance of the account. So that ends our account class. Now, to create the checking account derived class, we start out, we write a class checking account, and then to indicate that we're inheriting from the account class, we put a colon followed by public account. For this class, we're going to have one private field, and that's going to be a fee that can be charged when making a withdrawal from the checking account, like writing a check, for example, or using your ATM card. Under the public section, we'll start off with a constructor. The constructor will take two parameters, the beginning balance and an amount for the fee. We'll make that parameter f. And then right here, instead of the opening curly brace, we'll use a colon followed by a call to the base class constructor, account, with our balance. And then in the body of the constructor, we'll set f equal to the fee. Now we'll write a separate debit function from the base class debit, because in this case, we have to take out the fee. So the balance is equal to the balance minus the amount of the debit minus the fee, as you see there. Else, see out insufficient funds. And that's our last function that we have to declare. So let's go ahead and build the project to make sure it works before we write any test code. So let's test it out with a very simple program. So we'll call this my account, and we'll say we have $500 and the fee is 50 cents. Then we can test it. Let's add $100. Now let's check the balance. Let's do a debit. Let's do, say, $50. And then let's check the balance again. So we'll build and run the program. So there you see, we started out with 500. We deposited 100. Then we withdrew 50, and of course the 50-cent fee brought that down to $149.50. So it looks like our checking account class works. And again, the advantage that we had here is that notice that the checking account class, the only new pieces we had to add were the fee, and we needed to redefine debit to take into consideration the fee. But the other functions, credit and getBalance, did not have to be redefined because we could use them as is. And that provides the advantage to using inheritance when working with similar types of objects. So that wraps up this first exercise for the chapter, and we have one more exercise that we're going to work through next.